Hello everyone, today we will solve another equilibrium problem. Here the problem states in figure 39, which is this one, the greatest force at A or B caused by the 800 pound sphere must not exceed 10,000 pound. If a permanent deformation of the surface is to be avoided, find the largest value of theta may safely have. So let's draw a free body diagram for the sphere FBD, which is short of free body diagram. Here let's draw the axis as first. Here the sphere is pulling the whole thing downward. So the downward force here is 800 pound, and then the contact point at surface A, which is a vertical surface, it will put a reaction force perpendicular to the surface, which will be along the horizontal axis. So it will act in this direction. And for the B surface, at the contact point, it will be perpendicular to the B surface. So it will go along this direction, and this will be the angle theta. Now let's find the theta. So for that we have to consider the maximum force, which is 10,000 pound. Here, to pull the 800 pound upward or negate it, we have to need a force of 800 pound upward, and the A force, which is pulling it horizontally, it won't have any effect on 800 pound which is pulling downward. So ultimately it will all fall on the B force, which is pulling the whole thing upward and leftward. It is pulling the thing in leftward, which is also counteracting or counterbalancing the A force. So it is counterbalancing the A force and also the 800 pound. So let's assume the value of B as 10,000 pound, because it will be the highest force in between the A and B. So let's assuming B equals 10,000 pound. So let's apply Lamè's theorem. By applying Lamè's theorem, for that let's define the alpha, beta and gamma angle. Here let's take it as alpha, and this is beta, and this is gamma. For alpha, we can write it as 180 minus theta degree. For beta, we can write it down as 90 plus theta degree. And for the gamma, we can write it 90 degree. So let's write the Lamè's theorem here. For 800 pound, it is sine alpha, and for A force, the opposite angle is beta. So let's write sine beta, and then for B force, it will be sine gamma. So let's put the values in, then we will get sine alpha, which is sine 180 minus theta equals A, which is value we don't know, so we will keep it as A. And then for sine beta we can write 90 plus theta, and for B we assumed its value as 10,000, so let's put it down. And here the value of gamma is sine 90. So let's pick these two and solve the problem. It will be 800 divided by sine 180 minus theta, we can write it as sine theta by simplifying it, equals this one, which is 10,000 divided by sine 90, and we know the value of sine 90 equals 1, so we can write it as 10,000. Then we can find the value of sine theta, which is 800 divided by 10,000. Then we can write theta equals sine inverse (800 divided by 10,000). Therefore, theta will be sine inverse 800 divided by 10,000. Then we get 4.588, or we can write 4.59 4.59 degree, which is the maximum value of theta, or the largest value of theta. So if theta becomes 4.59, what will be the force at A point? Let's find out. For that we can write A sine 90 plus theta, we can simplify it as cos theta equals 10,000 divided by sine 90, or we can write it as A equals sine 90 equals 1, so we can write it as 10,000 into cos theta, and if we put the value it will be cos 4.59. Therefore A will be (10,000) into cos 4.59, it will be 9,967.93 pound. Here we can see that if we assume the value of B as 10,000 pound, we get A equals 9,967.93, which is lower than 10,000 pound, and for that we will get a theta of 4.59 degree. So this will be the largest value of theta if we don't want to exceed 10,000 pound limit. So that's the result of this problem. That's it for today, guys. Thanks for watching.